All right, 3.6 practice. Let's take a look at some of these problems. Make the screen a little bit bigger. We're ready to rock and roll. So number one, sketch the graph of the line. Nice thing is they give it to me in slope-intercept form. So remember, slope-intercept form is y equals mx plus b. This is our y-intercept. I always start there. It tells me where it crosses the y-axis. And then m is the slope, which gives me a change in y over the change in x. Rise over run, if you like to go that way. All right, so here we go. Number one, y-intercept would be at -2. So it crosses the y-axis at -2. And a slope of -3. Well, that's a slope of -3 over 1, which means we're going to drop 3 and go right 1. And then if I want to work back the other direction just to kind of get a little bit better line, you could do that. Now, the other option is, if you're not very good at slope-intercept form, you could always make a table, and you could choose a few x values and plug them x values in. You know, so you could say, well, I'm going to go a -3 times a -1 minus 2 and crank that out. That'd be 3 minus 2, that'd be 1. So now I have a point, -1, 1. You know, if you stick 0 in here, that'd be -3 times 0 minus 2, that'd be -2, which would be that point. If you pop a 1 in there, you get -5, which would be this point. So you'll get the same points. It's just a little bit slower making the table. But if that's all you got, run with it. All right, the next one crosses the y-axis, +1. Our slope is positive, so we're going to be going up 3 and over 4. Rise 3, run 4. If you stair step it down the other direction, it's going to be something like that. All right. Moving on down. This next one's a little tricky. Y equals x. It's an important line. It's a reflection line when you're doing transformations. The table is actually probably the easiest way to think about this. Well, if you put a -1 in for x, to make this equation work, you better get -1 for y. If you put 0 in for x, you're going to get 0 for y. 1, you'll get 1. 2, you'll get 2. So you end up seeing that it's this 45-degree line right here. It cuts perfectly through all those corners. Technically, though, it's y equals 1x plus 0. So if you think about it this way, our y-intercept is 0. Our slope goes up 1 and right 1, and you'll get the same exact line. Number 4 is not written in slope-intercept form. There's no y. So this one is not going to have a slope. And x equals 1, you know, if you think about a table, it doesn't matter what you put in for y. The only number that you could ever put in here to make this true is x has to equal 1. Y can equal whatever it wants to. Any of these numbers. And when you start graphing those, you know, 1, 0, 1, 2, 1, -3, 1, 4, any of them, you're going to end up with a vertical line. So moral of the story is, if it's x equals and you're missing a y, it's going to be a vertical line, and this has no slope. Or some textbooks refer to it as an undefined slope. All right, now we're going to write some equations here. So write the slope-intercept form. Well, you give me the m and you give me the b. Y equals slope. Don't forget your x. A lot of kids miss the x. And +3 is my intercept. Write slope-intercept form of an equation of a line. So I always need a slope and I need a point. You give me that, I can always write lines all day long. So they give me the slope, so that's cool. So I got a starter equation. I know it starts off y equals -3x, but I don't know what b is. So I got to solve for b, and luckily for me, I have an xy that lives on the line, which means it's a solution. So I can plug it in. 4 equals negative 3 times negative 1 plus b. And I got to solve for it. So 4 equals 3 plus what? And minus 3 from both sides. You're going to get b equals 1. So I now know the equation. It's y equals a negative 3x. We've solved for b, so we can put it in right here. It's a positive 1. Now, you could graph it and probably do the same thing if you'd like to do that. Graphing method always works, but I'm going to be showing algebra here, so I don't have to sketch a bunch of graphs. I have a fraction problem. Let's see what this one's talking about. This one looks a little weird. So my slope is 3/5. So y equals 3/5 x. And then, of course, I don't know my b, so we got to figure out what that is. Well, let's plug in some values here. For y, I'm going to plug in 1. For x, I'm going to plug in a negative 5. And we'll figure out what b is. Well, whenever you multiply a fraction times a whole number, like 3/5 times negative 5, you can just put a 1 under it and multiply straight across. So 3 times negative 5 is negative 15. 5 times 1 is 5. So that ends up being negative 3. So we have 1 equals negative 3 added to b. Add 3 to both sides. We figure out b is 4. So I go back to my original equation, and I get rid of the b, and I slap my 4 in, and we are good to go. Boom. All right, number 8. Same idea. Right slope-intercept form, except for now, you know, I need a slope, and I need a point, okay? But they didn't give me the slope. But they give me 2 points, so that's almost as good. So remember, if I want the slope, I got to do change in y over the change in x. So change in y is 5 minus a negative 2. Change in x is a negative 4 minus a negative 5. And that's going to give me 7 over positive 1. That's nice. So my slope is 7. So, starter equation. Y equals 7x. B, I don't know. Now it's dealer's choice. They give me 2 points. I can pick whichever one I want. I'm going to pick this one because it only has one negative, and I don't really like negatives. So 5 equals 7 times a negative 4 added to, I don't know. So 5 equals negative 28 plus I don't know. Add 28 to both sides. Wow, b is 33? Is that real? Man, that's making me nervous. I'm going to come up here and I'm going to put it in. Let's just see if I did something wrong. Both of those tables are supposed to be able to satisfy, both of these points should satisfy my equation. So I'm going to just check it. I'm a little bit nervous about that 33. It's awful big. So let's just see, does negative 5, negative 2 make this thing work? So I'm going to use this equation. Does negative 2 equal 7 times negative 5 plus 33? Man, it sure does. That one works. And the negative 4 or 5 works because that's the one I chose. So I guess that 33, no need to be worried about it. All right, next couple. Write the slope-intercept form. So I need a point, I need a slope. They don't give me the slope, but if you tell me I'm parallel to this guy, parallel means I need to have the same slope. So I got to be the same. So my slope's got to be 5. So I know my equation starts off y equals 5x plus, who knows? They don't ever give me the intercept. But I can now plug the x and y in. 2 equals 5 plus what? And subtract that 5 from both sides after you multiply by 1, but that's no big deal. You get b is negative 3. So you go back to your original equation, slap -3 in there, and we're money. Good to go. Number 10, I need to go through a point, but I need to be perpendicular. So remember, if I want to be perpendicular, I got to be the opposite reciprocal. I got to flip it and change the sign. So right now I'm 1/4. I need to flip it and change the sign, aka my slope needs to be -4. So here we go. Starter equation. B, who knows? Hopefully by now you're starting to see the pattern. I slap my x and y in there. -3 equals -4 times 2 added to something. -3 equals -8 plus who knows. Add 8. B is 5. So go back up here, take out the I don't know, slap the 5 in. And oh man, we're good. Looking real good. SAT problems. Graph of a line has a slope, contains the point. We did this one with algebra in class. I'm actually going to do it using graphing. I think this one works pretty nice. It gets kind of rough because it says if the two lines intersect at AB, what is the value of A plus B? So basically, you have two lines. So let's just kind of look at it like this. Line number 1 has a slope of 2, and it goes through 1/8. All right, and line B, or line number 2, I could calculate this slope, but when I'm graphing, it's just as good to have 2 points, 1, 2, and 2, 1. And then what's going to happen is those two lines are going to cross somewhere. And that spot where they cross is going to have an ordered pair. And they're calling it A and a B, but it's going to be two numbers. And the answer is going to be whatever those two numbers are added together. All right, so let's go to a graph. Let's actually take a peek at this. See if I can remember all this information. Boom. So we're going to go to a big old graph paper and get rid of that. And here we go. All right. So our first line, line 1, it went through 1/8. So right 1, up 8, puts me right about there. And that has a slope of 2. So it went up 2 over 1, up 2 over 1. Down, down, down. And I don't really even need to draw the whole line. I'll just put some dots. I don't know, maybe I'll draw it just for heck. Well, then line number 2 went through 1, 2, and 2, 1. So let's sketch that out. If you go through 1, 2, and then you go through 2, 1, well, you're this line. And I think I can see where they cross. I don't need to go very far. So the magic crossing point is right there, which is -1, 4. And then they want me to add those two together. So I believe the correct answer to this problem is 3. So correct answer is 3. So that'd be C. Number 12. Probably the hardest one on the sheet. SAT question. The line y equals kx plus 4, so we know k is the slope. K is a constant. That just means it's a number that doesn't change. It's graphed. If the line contains the point CD, C and D are not allowed to be 0. What is the slope in terms of C and D? Well, if you contain this point, just like we did on all these other problems, I should be able to plug it in. You know, so we got y equals, we're not sure about our slope. They do give me the intercept. That's kind of nice. But I'm going to plug in the C and D that work. So D is the y, C is the x, and I have plus 4. And I want to figure out what is the slope. Well, the slope is k. So let's solve for k. So to get k by itself, first I'm going to minus the 4 from both sides. And then to get k by itself, I need to divide by c. And it looks like we have d subtract 4, all divided by c. Correct answer is